Assignment number 8, problem number 1. Okay. So in this question, what they said, the currents in the RY, YB, BR means they are telling us that the sequence is RYB. Okay. That's why they did mention over here that R to Y, Y to B. Branches of a three-phase delta connected means delta is like this, right? It's better to draw the diagram always like this would be R, Y, B. By a three-phase symmetrical supply means it's a balanced load and 25 ampere is the current. They didn't mention it's the line current or the phase current. I told you if they didn't mention anything that we have to take the line current only, right? So IRY is equals to 25 ampere, and for this they said cos phi power factor is 0.8, right? Then they said 30 ampere means IYB. Sorry, it's not balanced because they give different current. So IYB is how much? 30 ampere, and for that cos phi they have given is 0.7, right? And then for IBR they have mentioned 20 ampere, and for that cos phi is equals to 1. Yes or no? Okay, so from here can we get the value, exact value of IRY in terms of polar? So polar would be 25, angle would be how much? Cos inverse 0.8, right? Cos inverse 0.8, and they said lagging, so it would be minus 36.87. Next one is IYB, that is 30 ampere, and phi is how much? Cos inverse 0.7, that is 45.57, and IBR is how much? 20, and they said ki unity power factor means angle is 0, right? Cos inverse 1 is 0. So from here basically we are getting the value of IR, Y, IYB and IBR. Got it? Now see what they have asked you, the magnitude of the current flowing in the line Y, right? So flowing in the line Y, as you know the formula also for the delta connected like IR, IY and IB, right? So IR is how much? IRY minus IBR. Remember I told you the formula, and this formula is also given in your handbook. RYB है तो R से start होगा and RP end, R to Y, B to R, right? IYB would be equals to, sorry, IY is equals to IYB minus IRY, and IB is equals to IBR minus IYB, correct? So we already have the values of IRY, IYB and IBR, correct? But for that we need to convert, or we can do it directly, or we need to convert it into rectangular form, right? So if I'll convert it into rectangular form, IRY, I already solved it, 20 minus J15, okay, and IYB is 21 plus J21.42, and this one is 20 plus J0, okay. If I'll substitute the value over here, IRY is 21 plus J21.42 minus 20 minus J15. So in this case answer is how much? 1 plus J36.42, okay. If I'll calculate the magnitude, means if I'll convert it into the polar form, that would be 36.43. So IR final answer, which you need to put it in your solution, that is 36.43, okay. This is IY, ये मैंने IY बताया है because they have asked you the IY only ना, IR उन्होंने पूछा ही नहीं है, right? The magnitude of the current flowing in IY is this one, and the magnitude of the current flowing in IB. Can you get IB value? So IB is how much? IBR is 20 plus J0, IYB is 21 plus J21.42, The final answer is -1 minus J 21.42 ampere, and that would be 21.44 ampere. Okay, so this is your 4-part question 1, question 2. Question 1 answer is this one, question 2 answer is this one. Okay, got it? Now see problem number 2. They said a 3-phase 440 volt RYB supply system is connected to delta. Means again it is delta. In delta we'll have the voltage is same and current is different, right? So the load they have given 20 kilowatt at UPF, means unity power factor, for RY phase. Okay, so 20 kilowatt means they have given you the power, right? So power they have given as 20 kilowatt. Unity power factor means cos phi is how much? 1, and they have given RY phase. For the second case, they have given us 30 kVA at 0.8 lagging power factor in YB phase. So kVA is the apparent power, so we can write it down. S is equals to 30 kVA, right? And cos phi is equals to 0.8. And for the YB, and for the third case, 20 kVA means S is equals to 20 kVA and cos phi is equals to 0.6. Correct? For the BR phase. Now they are asking 3 questions based on that the magnitude of the current in the line R, means we need to calculate IR value, right? So how can you get the IR value? Tell me. IR value, how can you get it? See, we'll have one formula that it's for the single phase. They have given that power is active power, so we'll have active power formula is V into I into cos phi. ठीक है, अभी उन्होंने पूरा का नहीं दिया हुआ, that's why I didn't use √3, right? So that would be power they have given, that is how much? 20 kilowatt. 20 means 20,000. Okay, voltage they have given, this is the line voltage or the phase voltage, both are same because this is the delta connection. So 20,000 is equals to 440, right? Current we don't know, and cos phi is how much? 1, right? So from here can we get the value for IPH? Can we get the value for IPH? Calculate it. Now see for the second case is this one. So in this they have given you the apparent power. So what is the formula? S is equals to V multiplied by I, right? S they have given as how much? 30,000. So mark it 30,000. Voltage we know that is 440, right? 440. And current they have given it for the IYB phase, so we can write it down like IYB, right? So if I'll calculate the IYB value, that would be 30,000 divided by 440. So the answer is 68.18, right? But from here we'll get the magnitude only. If they have given the angle, like they have given that is 0.8 power factor, so we can get the angle, that is cos inverse of 0.8. and they have mentioned over here that it's a lagging power factor. Lagging means the angle should be negative. So 68.18 angle is minus 36.86. This is the value of IYB. Got it? So we already got it the value for IRY from the first case, right? We get it IYB for the second case. Similarly, tell me the value for IBR for the next case. Now for the IBR case, IBR is equals to VBR by S is equals to V into I, right? No. S is equals to 1. S is equals to how much they have given? 20 kVA. So 20,000, voltage is 440, current is how much? IBR, right? Whenever they said na ki lagging, that means your angle is negative. Whenever they said leading, means your angle is positive. That's it. Okay. So IBR would be how much? 45.45. We now need to calculate angle. Angle would be how much? Cos inverse of 0.6. Cos inverse of 0.6, and they mention it's leading, so I'm taking plus sign. So 45.45 angle is 53.13. Correct? So this is IBR. Now see, we got the IRY value. Right, IRY was how much? 45.45 angle 0 degree. IYB value, that is how much we got it as 68.18 angle is minus 36.86, and IBR value 45.45 angle is 53.13. Right? In the previous question, we have done the same thing, but that it's a delta connection, and in the delta connection, we'll use VPH is equals to IPH into ZPH, or S is equals to VPH into IPH, right? Now see what they have asked you in the question. They ask you the magnitude of the current line R in R. So we need to calculate IR, as you know already, IRY minus IBR. So we need to convert it into the polar form. Rectangular form. So IRY and IBR is given. If I'll convert it into the rectangular form, and then your final answer would be 18.18 minus J36.36. If you convert it into polar form, that would be 40.65 minus 63.43. So this would be your final answer for the question number 3rd. Okay. And now question number 4, they are asking the reading on the wattmeter W1. So W1 is how much? Always IR into VRY. So VRY is how much? 440 angle 0. RY you already calculated, 40.65 angle minus 63.43. Right? If you'll solve it, then it would be 440. It would be 8,000 watt. Okay. Now they are asking the W2. W2 is how much? Always VBY into IB. So VBY, as I told you, VRY, VYB and VBR. So VRY is how much? 440 angle 0 degree. Right? For the next phase, angle is how much? 440 angle, tell me, minus 120 degree, and for this one 440 angle plus 120 degree. So VBY is how much? 440 angle minus 120 degree multiplied by IB. IB we need to calculate it by the same formula I told you. Like this is IR na, IB we need to calculate it by the formula. As you know, IB is equals to how much? IBR minus IYB. So you can convert it into rectangular form, then you will get the final answer of IB as 81.93, angle is minus 70.56 ampere. Okay, now I am substituting this value of IB over here. IB over here. IB is what? Which we have calculated 81.93 with minus 70.56. So the final answer would be minus 23440.77 watt. Okay. So this is for W2. So you can write it down in your formula page also, that particular if they'll ask you W1. W1 is always IR into VRY. W2 is always VYB into IP. Reason for this one, because generally we'll connect the wattmeter. Okay, it's the delta connection. तो delta connection में ऐसे ही होता है, तुम ऐसे याद ही कर लो. Don't go so much into detail. Just write down in your formula page. W1 means IR, first current IR. ठीक है. W2 means IB. VRY and VBIY. Got it? So IR value you know, IY value you know, and IB value you know. So basically in every question of delta you need to calculate IPH. IPH is how much? IRY, IYB and IBR. Then you need to get the line current. These are the phase current. Okay? And IR, IY and IB. These are the line current. You can write it down also. IRY is equals to IYB is equals to IBR. These are the phase current. IR is equals to IY is equals to IB. These are the line current. Okay, so you need to remember this formula, and that formula is given in your handbook also. Okay, now see the problem number third. Three non-reactive resistors of 3 ohm, 4 ohm, 5 ohm respectively are connected to star 3-phase 400 volt. Okay, so let's draw the star connection. Like suppose this is star connection, right? So this one is R, this one is Y, and this one is B, correct? So this one is 3 ohm, this one is 4 ohm, and this one is 5 ohm, correct? The voltage they have given is the line voltage because they didn't mention anything. So VL is equals to 400 volt, correct? So for calculation we need VPH. VPH in the star connection, what is the relation? That IL is equals to IPH, right? And VL is equals to root 3 VPH. So VPH is how much? VL by root 3, that would be 400 by root 3, that is 231 volt, correct? So now they are asking the calculate the current in the line current Y. IY basically they are asking, right? So IY is how much? So as you know, the line current is equals to the phase current. Yes or no? So in this case, IY we can consider it as VB IB, क्योंकि ABC की होगी तो ABC, RYB की है तो RYB, right? So for second वाला केस आ गया. So voltage should be how much? 231 angle is minus 120 degree divided by Y के साथ resistance is which one? 4 ohm ना, so divided by 4 ohm. ठीक है, I told you ना कि पहला एंगल इज 0 डिग्री, दूसरा एंगल इज minus 120 डिग्री, तीसरा एंगल इज 120 डिग्री, करेक्ट? Voltage, phase voltage is how much? 231. So we'll consider 231 angle 0 degree, 231 angle minus 120 degree, 231 angle plus 120 degree, right? So IY is equals to VPH divided by ZPH, right? So IY is equals to V over ZY, correct? V for the second case, Y है तो second case है angle 231 angle minus 120 degree, and Y का resistance they have given is 4 ohm, so 231 angle minus 120 by 4, correct? So that is 57.75 at an angle minus 120 degree. So its final answer is for the question number 6, that is 57.75 at an angle is minus 120 degree. ठीक है? If similarly you need to calculate IR, तो IR कितना होगा? 231 पहला केस है, right? तो angle is 0 degree, resistance is how much? Tell me. 3 ohm, right? तो ये हो जाएगा, that is 77 angle 0 degree. IY we have calculated. IB बताओ, IB कितना होगा? So IR IB कितना आएगा? 231 angle 120. तो R 0 डिग्री, Y minus 120 डिग्री, B 120 डिग्री. R का एंगल दिया हुआ है 3, Y का एंगल दिया हुआ है 4, B का एंगल दिया हुआ है 5. We can get the IB, IR, IY, right? तो इसकी वैल्यू आएगी 46.2 एंगल 120 डिग्री. ये मैंने एक्स्ट्रा में बताया, बट दे हैव आस्क्ड यू ओनली IY ओनली. ठीक है? नाउ क्वेश्चन नंबर 7. They ask you the total active power dissipated by unbalanced star connected is dash. तो active power they have asked, active power का formula is P is equals to VI cos phi. Yes, यही होता है active power का formula. √3 also, √3 VLIL cos phi, correct? But we don't have cos phi for any case, right? तो इस ऐसे केसेस में व्हाट वी कैन यूज फॉर्मूला फॉर द एक्टिव पावर, वी कैन यूज फॉर्मूला V स्क्वायर बाय R. ओके, पावर का ये भी फॉर्मूला होता है. सो VPH का स्क्वायर डिवाइडेड बाय R एंड R शुड बी R इक्विवेलेंट, राइट? सो VPH का स्क्वायर मल्टीप्लाइड बाय 1 बाय RA प्लस 1 बाय RB प्लस 1 बाय RC. RA, RB, RC वैल्यू है, VPH की वैल्यू है. आफ्टर सॉल्विंग यू विल गेट इट एज 41.8 किलोवाट. राइट डाउन द आंसर. RA is how much? 3 ohm, 4 ohm, 5 ohm. VPH is how much? 231. So after solving you will get the active power. ठीक है, दिस इज वन ऑफ द मेथड कि हमने ऐसे कर लिया. दूसरा मेथड था कि तुम इंडिविजुअल निकालते अलग अलग केस का. पावर का √3, वोल्टेज गिवन है और लाइन करंट गिवन है, cos phi निकालते. तो cos phi एंगल हो जाता है, जो भी तुम्हारे यहाँ पे एंगल आया ना वो वाला एंगल हो जाता. तो ये वाला ज्यादा इजी था. ठीक है, एक तो मेथड जो मैंने बताया, एक मेथड है P का फॉर्मूला होता है 3 VPH IPH cos phi, राइट? 3 एज इट इज है, वोल्टेज इज 231, राइट? करंट तीनों के केस का अलग अलग आ रहा है. IR का 77 एंगल 0 डिग्री, राइट? तो 77, phi एंगल इज 0 डिग्री, सो cos 0. ठीक है, सिमिलरली यू नीड टू गेट सेकेंड पावर. सेकेंड पावर का करंट इज हाउ मच? 46.2, एंगल इज 120 डिग्री, राइट? तो 3 231 46.2 इंटू cos ऑफ एंगल कितना आ रहा है? 120 डिग्री. सो cos ऑफ 120 डिग्री. सिमिलरली तुम R का निकाल लिया, Y का निकाल लिया, B का निकाल लिया, एड इट. तो दैट वुड बी इससे ज्यादा बेटर है कि ये वाला फॉर्मूला यूज कर लो. ओके, नाउ आफ्टर दैट the next question, question number 8, the neutral shift voltage, that is potential between neutral point of load and neutral. क्योंकि स्टार में will have the neutral ना, तो basically they are asking VNO. तो VNO का फॉर्मूला is VAN by RA plus VBN by RB plus VCN by RC divided by 1 by RA plus 1 by RB plus 1 by RC. अब देखो, तुम्हें देख के लग रहा होगा कि ये कहाँ से आ गया फॉर्मूला. कुछ नहीं है, ये V is equals to I by R होता है. So R should be R equivalent, yes or no? And R equivalent is how much? 1 by RA plus 1 by RB plus 1 by RC, yes or no? Okay, so I is how much? V by R we can say. So it would be VAN by RA. तो तीनों का सम लेंगे, VBN by RB and VCN by RC. ठीक है, VAN you already know that you have calculated. VAN is how much? मतलब ये तुमने पूरा करंट ही कैलकुलेट कर रखा है, राइट? तो इसको मैं ऐसे लिख देती हूँ, I कैन वी राइट इट लाइक IR प्लस IY प्लस IB, ये लिख सकते हैं. चलो ये बताओ, V वोल्टेज पूछी है न्यूट्रल के अक्रॉस, तो वोल्टेज का फॉर्मूला, नहीं ये मैंने गलत लिख दिया. V इज इक्वल्स टू IR होता है ना, तुमने भी नहीं बोला. तो इसको पूरा हम सॉल्व करेंगे तो विल गेट द आंसर, दैट इज 77 एंगल 0 प्लस 55.75 एंगल माइनस 120 प्लस IB कितना आ रहा था? 46.2 एंगल 120 डिग्री divided by 1 by RA is 0.33, 1 by RB is 0.25, 1 by RC is 0.2. So the final answer for this one is 31.96 volts. Write it down. सॉरी फॉर दैट, वो मैंने फॉर्मूला गलत बोल दिया. तो हमारे पास वोल्टेज निकालनी है, राइट? तो VNO, तो उसको मैं ये लिख सकती हूँ I डिवाइडेड बाय 1 बाय R इक्विवेलेंट. ये लिख सकते हैं ना, 1 बाय टोटल R. तो I क्या हो गया? द I इज IR, IY and IP, right? And R equivalent is 1 by RA, 1 by RB and 1 by RC. तो ये आ जाएगा तुम्हारा फॉर्मूला. तो ये फॉर्मूला डायरेक्ट एक बार अपने फॉर्मूला पेज पे लिख लो, बिकॉज दिस फॉर्मूला इज नॉट गिवन इन योर हैंडबुक एंड समटाइम दे आस्क यू द न्यूट्रल शिफ्ट वोल्टेज. तो यहाँ पे मेंशन कर लेना फॉर्मूला बुक पे दैट दिस इज द फॉर्मूला फॉर न्यूट्रल शिफ्ट वोल्टेज. ठीक है. नाउ प्रॉब्लम नंबर 4, they said balanced है कि balanced कौन सा connection है, star. So that means VL is equals to √3 VPH and IL is equals to IPH. तो सबसे पहले whatever they have given star or delta, write down your own formulas. Okay, that in the star connection we have to use this formula. Now they have given the voltage, they didn't mention, so it's the line voltage, that is 440 volt, and they have given the value ZR is equals to 100 ohm, ZY is equals to J5 ohm and ZB is equals to minus J5 ohm. Okay, now read the first question. This is the given part, that the magnitude of the voltage across R phase, means they are asking voltage, right? And across R, so VR is equals to how much? VR. For that we need to calculate, this is the line voltage, right? We need to get the phase voltage. So phase voltage is how much? VPH is equals to VL by √3, that is 440 by √3, that is equals to 254 volt. So its answer is only 254 volt. चाहे वो R के across पूछे, Y के across और Z के across, because they have mentioned it's a balanced connection, so voltage for each phase would be same. ठीक है. Now in the next part they are asking the magnitude of the voltage or B of phase of the load. Again it is 254, sorry zero नहीं आएगा, 254. If you want to write it down the angle, तो R के केस में angle is 0 degree, right? And Y के केस में angle is minus 120 degree, and they are asking B, तो B के केस में angle is plus 120 degree, right? ठीक है. Now see the next part, the magnitude of the neutral displacement voltage, that is potential between neutral point and earth, right? So basically they are asking Vn, write down the formula for that, VR into ZR, Vy into ZB plus VB into ZY divided by ZR plus ZY plus ZB. तो ये न्यूट्रल के केस में सी ये वाला फॉर्मूला भी कुछ इसी टाइप का था, V इंटू, तो अनबैलेंस के लिए था, ये बैलेंस के लिए. सो अगेन दिस फॉर्मूला इज नॉट मेंशन इन योर हैंडबुक, राइट डाउन दिस फॉर्मूला in your formula page for the balanced star connected neutral voltage. वो वाला था unbalanced star connected neutral voltage. Okay, so Vn is how much? VR into ZR. VR is how much? 254, angle 0 degree, right? So I'm writing down the separate value. Vy is how much? I told you 254, angle minus 120 degree, right? VB is how much? That is 254, angle 120 degree, right? See in the previous case they specifically mention कि magnitude बताना है, तो तुम्हें angle नहीं लिखना, ठीक है? वैसे मैंने बता दिया था angle, but you don't need to write it down in your sheet because they have specifically mentioned that you have to write down magnitude only. Okay, so VR, Vy, Vby I told you, ZR is how much? 100 ohm. ZY they have given J5, ZB they have given minus J5. So you just need to substitute the value only, then you will get the answer. Okay, and I'm telling you the direct answer after substituting all this. Your answer, neutral displacement voltage is VR into ZR we need to do. That would be 254 into 100, right? Vy into ZB, Vy is 254 angle minus 120 into minus J5 plus 254 angle, VB का angle is 120 degree multiplied by ZY, J5 divided by sum. Sum is 100 plus J5 minus J5, है ना? तो J5 से J5 would be cancelled, yes or no? After solving you will get 254 only. This is the final answer. Just see it. If you have any doubt then let me know. Now after that, if the current coil in the wattmeter was inserted in Y and the pressure coil was shorted at line B, तो अगर उसको short कर दिया and wattmeter is at Y, then the reading of the wattmeter is 0. Okay, 0 kilowatt. Because ये तुम्हें अभी ऐसे समझ में नहीं आएगा because I didn't tell you by the diagram the wattmeter method. When I'll tell you about the detail of wattmeter, तो इस question को मैं लूँगी. For the time being, you can write it down as 0 kilowatt because Y and B are orthogonal and their power is 0. Okay. Now, question number 13. They are asking if the neutral point is shorted to the neutral point of the supply, then the current in the neutral wire. So, IN is always how much? You know, IN is always equals to, I told you, addition of all three. तो magnitude is IR का square plus IY का square plus IB का square. ठीक है? IR we need to calculate. IR is how much? That is 254 angle 0 divided by ZR. है ना? ZR is 100 ohm. IY is how much? So 254 angle minus 120 degree divided by ZY. ZY is J5. And you tell me about IB. So after solving it, we'll get it as root of 5170.73. That would be 71.93 ampere. ठीक है? इसको solve करके I'll tell you the value. We'll get it as 6.45. इसको solve करके we'll get it as 2581.64. And this one would be 2581.64. Angle we didn't consider, so only magnitude. Okay, so the final answer is 71.93 ampere. Got it? Now see, in this question they have said three impedance. Line voltage they have given means VL is equals to 440 volt. So VPH is how much? 440 divided by root 3. That is how much? 254. Right? So VR is how much? 254 angle 0 degree. VY is how much? 254 angle minus 120 degree. VB is how much? 254 angle plus 120 degree. Okay, now this value we have to use. After that they have given the current in Y. IY they have given is 10 angle 90 degree. IB they have given is 20 angle 90 degree. Correct? Now they have given the neutral shift voltage is this one. एक इन्होंने neutral voltage दे दी. That we just need to, what we need to do, that subtract. Like suppose इन्होंने क्या पूछा हुआ है question में, magnitude of the resistance Y. Basically we need to calculate ZY. ZY is how much? VY divided by IY, right? So VY is how much? 254 angle minus 120 degree divided by IY is 10 angle 90 degree, right? But due to this neutral shift voltage, we need to do one thing extra. उसको वोल्टेज में से सब्ट्रैक्ट कर दो, एवरी वोल्टेज, ठीक है। whenever they'll give you the supply neutral voltage, then you need to subtract this voltage from the main voltage. That's it. Clear? Now after solving, you should get in the rectangular form, R plus JXL, right? Because they are asking resistance only. So after solving, you will get it as 32 ohm. ठीक है? Now similarly they ask you magnitude of capacitance. Capacitive reactance means they are asking XC, right? So again we need to calculate ZB. ZB in the form of R minus JXC, right? So XC they have asked. Now tell me, how can you get ZB? So ZB we need to calculate, that would be VB by IB. VB is how much? 254.03 angle 120 minus, again we have to do it neutral wala, 200 angle 150 divided by 20 angle 90, right? So after solving, calculate the capacitive reactance. We need to get it now, so we need to get it by form of R minus JXC. After solving, we'll get it as 2.31 ohm. XC is 2.31 ohm. Okay. C, for this we need to calculate ZR. ZR is VR by IR. VR is this one, angle 0 minus this one. So in this neutral is 0. So IR plus IY plus IB is equals to IN. ये formula होता है. So in this there is no neutral current. Neutral is 0. So can we say that IR would be equals to minus of IY plus IB? Yes or no? IY we have already calculated, they have given 10 angle 90, and IB also they have given, that is 20 angle 90. We can solve it, then we'll get IR and we can substitute it here, right? So ZR is VR by IR. VR we calculated, IR we calculated. ZR after solving it, you will get it as 14.63 ohm. Okay, 14.63 ohm. Write it down. Now next question. In this they have given the wattmeter. See, I told you I'll tell you the exact wattmeter. So always we'll connect wattmeter in R sequence and generally Y sequence. They have connected in R and B. Okay. Voltage, line voltage VL is equals to 400 volt, right? So we can say that VRY is equals to 400 angle 0 degree, right? VYB is equals to 400 angle minus 120 degree. VBR is equals to 400 angle plus 120 degree, correct? The phase sequence is this one, and the reading of the wattmeter 1 we need to calculate. So how can we get reading of the wattmeter 1? I told you the formula now. So basically you need to get IR, right, for wattmeter 1. But see, there is a change. What is the change? Wattmeter 1 is connected across. If we take the current, this is IR, and the voltage between R and B is VRB, right? So in this case, wattmeter 1 formula is IR into VRB, because this is connected between R and B. Okay. Now for wattmeter 2, the current flowing here, it would be IB. Sorry, I not B Y, it's IB, right? So IB multiplied by wattmeter is connected between B and R, again VBR. ठीक है. So that depends कि they can connect wattmeter over here also. तो R Y के देखते हैं, उसके according देखते हैं. अब जिस current में connected है, R में connected है, so we'll take IR and IB, and the voltage इन दोनों के बीच में है तो VRB. Okay, clear? So basically we need to calculate the current over here, that is IR, right? So how can we get IR? Tell me. For it's a star connection, IR we need to get it, right? So can we say that IRY, like that would be 400 angle 0 degree divided by 10J. We have to see it according to the diagram. See, so for this particular case, it is between R and B, right? So can we say that ZBR is equals to 10 ohm? Yes or no? This is between R and Y, right? So can we say that ZRY is equals to J10 ohm? Why J10 ohm? Because it's an inductor. Okay. Now this is between B and Y, right? So ZBY is how much? That would be capacitance is there, so that would be minus J20 ohm. Okay, clear? So now you'll have ZBR, ZRY, ZBY, and you'll have the voltage also. Can you get the current? By using KVL or by using KCL, you can use it. Okay, I'm telling you the direct answer. This one would be 29.856 kilowatt, and this one would be 22.928 किलोवाट. ओके, उसमें पूरा तुम्हें KCL एंड ऑल अप्लाई करना पड़ेगा. अब देखो, अगर किसी को ये क्वेश्चन समझना है तो मुझे व्हाट्सएप पे तुम कांटेक्ट कर सकते हो. और एज यू नो योर पेपर इज वेरी नियर, राइट? इट्स इन अप्रैल एंड. सो इफ यू वांट कोचिंग एंड इफ यू वांट एनी 15-day क्रैश कोर्स, तो मैं पूरा BT का कोर्स आई विल कंप्लीट इट. Okay, if you want to coaching for B or for BT, then let me know. Within 15 days only I'll complete this subject, B or BT. Regarding fees, you can contact me on this number, and if you want only doubt classes, then also you can contact me. And if you want key, I just want to do the some particular topics only, ma'am, some of the topics I know, so for that also you can contact me. And best of luck for your exams. Bye bye.